But Mr. Kazim, some people don't have like I have, but my printer isn't working, and we don't want to go outside. How am I gonna do it then?
Okay, good. Uh, Guys, if you do not have a printer, you don't have to print it out. I'm just saying that if you have a printer, I just suggest you to print out the papers and after that do it. If you don't have a printer, you don't have to print it, okay? You have a telephone, maybe you have an iPad or you have a tablet, right? Look at the question and just do them in the notebook, okay? Or in the A4 size paper. You don't have to copy the question, just do it. Here, we are here to learn something, okay? So important thing is doing the question, practicing the questions. I just want to see how you're solving the questions. Can you solve the questions or you don't understand anything? I just want to see this, okay?
Okay.
Guys, now let's continue then, okay? Uh, Everybody, if you are listening to me, just listen carefully. You are like maybe you're 10 years old, 11 years old, 12 years old. All right. So maybe this is your first time learning math at this pace. All right. Maybe, I don't know, you have some experience or not, but sometimes it takes time to get used to learning like this. Now we are having intensive mathematics course. Okay. So that means that I'm going to teach you, but what you're going to learn in math maybe in 1 year, here you're going to learn this maybe in 3 or 4 months. All right. And that's why uh, just let's just be patient for maybe 1 or 2 weeks. Okay. I just keep explaining everything. What you have to do is now I will send you a question in WhatsApp. Just have a look, download this and solve it in the notebook and send it to me. And let me see, is everything okay or not? If not okay, I will explain. Nazlı, look, you should not do like this, or your work is very good, or it's fine. Okay. I will give you some comment or feedback. In this way, you will improve, okay, and also learn how to study online math like this.
Mr.
Now, the first month, let's just learn, okay, as much as we can. After that, we will start practicing. And after that, we will start solving SASMO type questions. But now, you need to learn something. Let me just see your learning skill. Do you understand everything or not?
Yes,
Yasmin, is
yes.
it clear?
Yeah, I have a question. Can
Yes.
we solve it in like a Google document or in some sort of online form and then just send you the answers, or do we have to do it with a solution?
No, no, guys, look, you don't have to send me, okay? You have to send me if you have any question. Like, for example, let's say, let me just show you how to do that, okay? Like, uh, all right. Now you can see my screen, right?
Yes, yes,
Yes,
yes.
yes.
Okay, good. Now, look, I just categorize everything and put your files here. As you see here, we have grade 6, 7, 7A. This grade 6, this is your folder. I put everything into this folder. And I open this, we have topics, just 5 of them. This is my plan for 1 month. And factors and multiples. We have lessons and slides that I'm using to teach you in online class, learning materials, some additional materials, and homework. If you open homework, I'm just going to send this to you, all right? I have already sent actually. If you just open one, for example, let's say, let me just open one, open with Microsoft Edge. This is your homework, okay? How to do this. For example, let's say, uh, let me just say one question.
3 of
Here,
them?
let me just do only one of them. Question 5, okay? So now on the telephone, you can read the question, right? And on the table, you have a notebook or paper, okay? Just read the question, understand, and do it in the notebook. What is the question here? Let me just unlock this a little bit. So Nazlı, can you see the question? Question 5.
Paul has three pieces of rope with length of 140 centimeters,
Okay.
168 centimeters, and 210 centimeters.
Okay.
He wishes to cut the 3 pieces of rope into smaller pieces of equal length with no remainders. What is the greatest possible length of each smaller piece of rope?
Okay. Now, Nazlı, you can see,
Okay,
right?
I think
No, Nazlı, look,
Oh.
I just want to know. Actually, you can see, you can read the problem. Now you read the problem. Now you have to solve. Where you should solve the problem? You should solve in a notebook, okay? If you can solve it, if you can understand the question, I have already shared the answers, okay? You open the answers. For example, question 5. What is it? It is exercise 1C, question 5, okay? Let's solve this first, how you are doing your work. Now you read the question and suppose that I have some more space. Guys, let me just open a little bit more space, okay? So just give me a minute. All right. Okay. All right, I just reopened this. I just have more space to solve this, okay? So now we are going to solve this. Let's just solve question 5 since we just opened this, okay? So what is the question? Paul has 3 pieces of rope with length of 140, 168, and 210. And he wishes to cut the 3 pieces of rope into smaller pieces of equal length with no remainders. So how do we solve this? Question A, it says that I'm just solving in my notebook. What is the greatest possible length of each of the smaller piece of rope? Okay, to do this one, to find this one, we need to find the highest common factor of this one, right? He wishes to cut the 3 pieces of rope into smaller piece of equal length with no remainder. The first question is, what is the greatest possible length of each of the smaller piece of rope? Now here we have 3 different pieces. Let's say this one is the first piece, and this one is a bit longer, the second piece, and third one is a bit longer, third one is. The first one is 140 centimeters, second one is 168 centimeters, and third one is 210, right? So it says that it is the greatest possible length. Neil, I have a question for you. Instead of greatest, if I ask you, what
Oh,
is...
may I say? I know what you want to say. Greatest
What?
means bigger, like plus.
No. My question is, instead of greatest, if I ask my question like this, what is the shortest possible length of each of the smaller piece of rope? How would you answer this question?
Maybe like the smallest one is 140, but like if it asks like that, I will like go from the smallest one, like 110. I will like do the ropes like smaller.
So
Can
actually,
I
the
answer?
common factor of these numbers, it will be 1, right? Each one, actually,
Yes.
each rope is 1 centimeter, 1 centimeter, 1 centimeter, right? I can cut like
Yes.
this. We have a lot of cases, but here it says the greatest. To answer this question, so we have to find a number, right? All of these numbers are divisible by that number. So that means that we need to find the highest common factor of these numbers. So how do you answer this question? So write
Can I tell you?
140, 168, and 210. Guys, just I want to say something. Just wait, okay? Now let's find
common
this.
factor or highest factor for each of them.
Yes, we need to find the highest common factor of these 3 numbers. So what is it? Divide by 2. All numbers are divisible by 2. 70. This one is 84. This one is 105. Okay, that's a common factor. Now all of these numbers are divisible by 2. No. But so let me just divide by 2. Here we have 35. Here we have 42. Here we have not divisible, 105. Now still 42 is divisible by 2, but it's not a common factor. 35, 21, and 105. Now all of these numbers are divisible by 5, right? Let's say this, okay, let me just divide by 3 first. If you divide by 3, 35, and this one is 7, and this one is 35. Now all numbers are divisible by 7. If you divide by 7, here we have 5, here we have 1, and here we have 5. Okay, so I can just stop here. This 5 also only dividing this number and this number. Anyway, so this 2 and this 7, these are the common factors. So how do you find the highest common factor of these numbers? That's just 2 times 7, that's equal to 14. So I need to cut these ropes into equal length where each length is 14 centimeters. So question A, your answer is 14 centimeters, right? Guys, look, you are doing this one. Now your answer is correct or not. How do you know that? Now you have to check this. I have already shared the answers. Let me just open the answers here. We have answers. What question did we have just solved it? That question is, what question is it? It is exercise 1C, question 5A. Look at this here. If you open this, okay. Exercise, is it 1C? 1C, right? Where is 1C? Question 5. So here,
Sorry,
as you
I'm
see
late.
here we have, right, question 5, exercise 5C. The answer is 14. So your answer is correct. You just take and continue. If you solve this, your answer is not the same as the answer in the book, then you should bring this question to the class. Mr. Qasim, I solved this question, but my answer is different. We solve only those questions together. But I'm not actually, you don't have to send your notebook, homework to me. Just you have to practice. I'm just sending the question for you to practice. You have to practice those questions. Okay?
And yes, may you please go to the other, like the one that we did? I have one question about that.
You mean this one?
Yes.
Yes.
Why did you just take like 2 and 7 out of there's 3 and 5 and 2 and 2?
Because we are looking for the numbers, right, that divide all of these numbers together. Not only one of them, all of these numbers. Those numbers are, we call this common factors, right?
Yes.
So in the question, it is asking the greatest possible length of each of the smaller piece of rope. So our purpose is, we have to cut these ropes into equal length, but actually each length must be the maximum, the greatest, the longest. So that means that we need to find a number that should divide 140 and 168 and 210 together. Simultaneously.
Do you mean like when you plus these together equals the biggest one? That's why you chose 7? Do you mean by that or no?
No, for example, let me just give a simpler example. How about if you have only 2 pieces of rope? Let's say one is, okay, one is, let's say it is 6 centimeters. Another one is, let's say here we have 10 centimeters, okay? But actually, you are just going to cut into smaller pieces. But actually, you have 2 conditions. Number 1 is, you want actually each piece the longest as possible, and all of these pieces must have equal length. At that time, how can I do that? I should find a number, the biggest number, right, that divides 6 and also 10. What is the biggest number that divides 6 and 10? That is highest common factor
2.
of 6 and 10. That's equal to 2, right? So now I can cut this into
Yes.
smaller pieces. So if I do so, at that time I will have 5 pieces. The first one is this one, 2 pieces, and this 2 and this 3. Actually, I got this from the first part, right? From the second one, I can cut this into 5 equal length, right? It is 1, 2, 3, 4, and they are all equal, and 5. Now all of them are equal, because you don't want to waste any piece of rope. That's why. Okay. All right, boys and girls, you should do your homework like this. Okay, when you look at the question, solve it in the notebook, and you have the answers, compare with the answers. Did you solve it correctly or not? If it is correct, it's fine. If your answer is different, then you should bring those questions into the class. Mr. Qasim, I solved this question, but my answer is different. How do we solve this problem? This is how you should do your homework. Okay, Neil, is it clear, Yasmin?
Qasim,
Yes,
Yes.
it's clear for me, but I'm
I have
like
question.
50-50.
Can you explain how to get HCF? I forgot.
Okay, now we are going to practice. Now here, I'm just showing you how to do your homework, okay?
But do you call this HCF? This one that you did, like 142.
Yeah, this HCF means the highest common factor. Okay, now we will do some practice. Okay, guys, if you understand how to do your homework, now we are getting back to our class. Okay, here's somebody else. I did it just now. It is 2, I think. Yes, that's right, Nazla. Okay. Guys, now can you see my screen? Sadiq, can you read the question?
Yes,
Yes.
you can see the screen.
Find the highest common factor of 60, 180, and 210.
Very good, very good. Okay, just guys, 1 minute break. Okay, let's have a break, 1 minute. Continue. Guys, how many students we have here? Sadiq, you are here. Let me just have a look quickly. Okay, Sadiq and Nazlı, Yasmin, Shamil, Neil. Any more students?
We have
And,
8 students.
Eight here, right? Okay.
And Mr. Kazan, while we were learning this, but it was called another thing. It was called GCF. We didn't call it HCF. We called it GCF.
Very good. Yes, yes, you are right. Some books, they just say that GCF.
Yeah, there's
Okay,
Yes,
some
we
books
learned it.
HCF.
I
And some books
remember.
like, yeah, it's the same thing. This GCF means greatest common factor or highest common factor. They mean the same thing.
Because I remember like it was like last year or something. We learned about this. You did the same. I was like, but ours was called GCF if I'm not mistaken. And now I want to see.
Mr. Qasim,
Yes, Sadiq. Sadiq,
We
just
have-
1 minute, keep your question.
yes.
Neil, about this, okay, guys, you are studying, maybe some of you at public school, some of you in private school. Okay, you should understand one thing, all right? In the world, we have a lot of different countries. Okay, in Azerbaijan, maybe you follow schools, actually Russian curriculum, and maybe some private schools, they follow Cambridge curriculum, and some other countries, they follow American system. Some people, maybe Singaporean system. Okay, but after all, names may be a little bit different, but they mean the same thing. Okay, but here, as you see, greatest or highest, they mean exactly the same thing. Some people want to call this greatest, some people want to call this highest, but in Singapore books, actually it is called highest common factor. Okay, so actually they are the same thing. Yes, Sadiq, what was your question?
It wasn't a question. I was just wanted. So we have learned GCF and LCM.
Yes, that's right.
Us, we also learned GCF and LCM.
Yes, exactly. We are just learning, but actually, I know that you have already studied maybe in grade 4 and 5. Now we are learning them a bit deeper, okay? So we are going to see a little bit more complicated and more difficult questions, all right? Okay, now guys, let's continue. What you have to know is, it's very simple. Okay, last time, what did we learn? We learned prime numbers. What are the prime numbers? If you remember, actually, a whole number, right? A number which has exactly two different factors. We call this a prime number, right? It's like, okay, this one we call this computer. This one we call this smartphone. Now this one we call this a calculator. Like this, also in math, every term has a name. Some numbers we call them prime numbers. Some numbers we call them natural numbers. Some numbers we call them whole numbers, real numbers, rational numbers, irrational numbers, okay? So what are the prime numbers? If you remember, prime numbers are 2, 3, 5, 7, 11, 13, and 17, 19. It continues. Now to find the highest common factor or least common multiple, it doesn't matter. To write this one, I'm just saying that there may be some different methods. What we are learning here is write these numbers 60, 180, and 210, and draw a line. Okay. Now starts, for example, start dividing these numbers by the smallest prime number. Okay. So as you see here, all numbers are divisible by 2. If you divide by 2, so 2 is dividing all the numbers. Let me just put a star. Why? Because to find the highest common factor, we have to multiply the start numbers together. To find the least common multiple, we have to multiply all of these numbers together. So if you divide 60 by 2, it is 30. 180 by 2, it is 90. 210 by 2, it is 105. These 30 and 90 even numbers, still we can divide, but now 2 does not divide 105. That's why I don't put star for this. 30 is divided by 2, it is 15. 90 is divided by 2, 45, and 105. So none of these numbers are even. So we are done with 2. What is the next prime number? Now I try to divide these numbers by next prime number. That is 3, right? So if you divide by 3, 15 is divided by 3, it is 5. 45 is divided by 3, it is 15. 105 is divided by 3, it is 35. As you see here, 3 is dividing all the numbers. That's why I put a star. Now, next one is still this 15 is divisible by 3. Let me just divide by 3 here. Here we have 5. Here we have 5. And 35 is not divisible by 3. 3 does not divide 5. That's why we don't put a star here, right? Now, we are done with 3. The next prime number is 5. So try to divide these numbers by 5. If you divide by 5, 5 is divided by 5, it's 1. 5 is divided by 5, it's 1. 35 is divided by 5, it is 7. As you see here, 5 is dividing all of these numbers. That means that 5 is a common factor of 5, 35. So now only one number is left, divided by 7, so that's equal to 1. Now to find the highest common factor, what is it? Highest common factor of 60 and 180 and 210. We should just multiply the start numbers. Why? Because these numbers are common factors of these numbers. If you multiply them together, it gives us the biggest, the greatest, the highest of these common factors. So that's equal to 2 times 3 times 5, which is equal to 2 times 3, 6. That's equal to 30. So the highest common factor of these numbers are 30. What does it mean? It means that if I just write here, they have common factors, right? What are the common factors of 60, 180, 210? Highest common factors of these numbers are, it is 1, it is 2, it is 3, it is 5, 2 times 3, it is 6, sorry, it is just 6. And 2 times 5, it is 10. 3 times 5, it is 15. And multiplication of all of these numbers, it is 30. Actually, these are the common factors of these numbers. But here, among these numbers, which one is the greatest? The 30 is the greatest, right? Yes. That's why actually we found here it is 30. Okay, as you see here, there's only 2, 3, and 5. These are the prime numbers. Other numbers are not prime, composite. How do you obtain 6, for example, 10, for example, 15? Just using this 2, 3, 5, right? That's why actually prime number concept is important. We have to first find the prime factorization of a number. Then we actually solve this kind of problems. Okay, that's the first part. Let me finish. After that, I will answer your question. How about the least common multiple? Least common multiple. Sadiq, how did you call this least common multiple?
We called least common multiple.
The same, right?
Yes.
Okay, good. Then least common multiple is the same. Okay. And how about, how do you find the least common multiple of 60, 180, and 210? Just we need to multiply all of these numbers together. So that is 2 times 3 times 3 times 5 times 7. That's equal to 2 times 3, 6, 6 times 3, 18, 18 times 5, 90, 90 times 7, that is 630. Okay.
Yes.
Yes.
Very good. That is the highest common. Now, guys, let's talk about least common multiple. We already did example, but actually, let's talk about some problems about least common multiple. Sadiq, can you read this problem?
Yes. Mary, the art elective program student, is working on a second assignment. She first designed a rectangular pattern measured 9 centimeters by 12 centimeters. She then makes copies of rectangular pattern. Next, she uses the rectangular patterns to form a square. How many rectangular patterns does she need to form the small square? And what is the length of a side of this square?
Okay. That is one problem why we should learn about least common multiple, right? In our daily life situations, actually we use this problem a lot. What is the problem here? You have a rectangular tile, right? We call this rectangular tile. So what is this? Here we have rectangular tile. So the length, width is 9 centimeters and length is 12 centimeters, right? But you are going to design something using these rectangular tiles. What is it? We are going to design something, but actually it should be square shape. All of the sides must be square, as you see in the picture, right? So this one is square, this one is square, the rectangle, and the whole thing is square, right? What is the question? If you are actually laying your tiles in this position, right? This one is 9, this one is 12. As you see in the picture, this is 12 and 9. So here, how many tiles can I put here? And how many tiles can I put here? Now, to answer this question, since one side of the tile is 12 centimeters, right? That means that the side of the square, it must be divisible by 12, right? Because what are the possible answers for the length? Let's say this square, let's say this side is A and this side is A, right? What are the possible length? If I'm talking this about 12, right? How many times I put here? If I put only one, the length will be 12. If you put two, it's 24. If it is 3, 36. If it is 4, 48. If you just put here, continue putting here 5, it will be 60 continuous. And how about in horizontal direction? We know that the width of the rectangle is 9. At the time, the square side will be, if you put only one, it will be 9. If you put 2, it will be 18. 3, it will be 27. 4, 36. 5, 45. 6, 54 continues, right? So what is the question here? It says that how many rectangular patterns does she need to form the smallest square? Here is a keyword, not any square, the smallest one, okay? So to be the smallest, actually one side of the square cannot be 12 because 12 is not divisible by 9. And 24 also, it is divisible by 9, but 12, but not divisible by 9. So what is the smallest number that is divisible by 12 and 9? The smallest number, as you see here, it is 36. And if we just continue this, next number will be 72. Next number will be 1/8. So among these numbers, let me just write here, common multiples of 9 and 12. So what are the common multiples of 9 and 12? Those are 36.
36.
Next one is 72. Next one is 108. Next one is 144, and continues to infinity. It never stops. But here
Mr.
we are interested in the smallest one, right? Among these numbers, which one is the smallest? The smallest is 36. So now I'm giving a special name to this. Then list common multiple of 9 and 12 is 36.
But Mr. Kazim, I have two questions
Yes.
about this. At least common multiply, like this thing that you showed, this is how we do it. But the last one, the last page, you showed that we multiplied.
Yes. Now, actually, as you see here, every time finding this way, it's not so practical. It is very long. So how do you find this in a shorter way? Let me just find this. Here, to find this one, let me just draw a line here. We are talking about two numbers, right? If I use that method, you will see that it's much, much easier. 9 and 12, right? So divide by 2, it is, I cannot divide 9 by 2, so it is 6. Divide by 2, it is 9 and 3. Now I can divide both numbers by 3, it is 3 and 1. And divide by 3, here we have 1. When we have 1s, we just stop here. So now list common multiple of 9 and 12 is equal to 2 times 2 times 3 times 3. That is 2 times 2 times 3 times 3, which is equal to 36. Now, which one is easier, this method or the previous method? As you see, wait,
Mr.
actually,
Kazim,
this
I
one is,
also have another question.
yes.
In this one, why didn't you use 3? Yeah, here. Why didn't you use 3? You can use like 9 divided by 3, and 12 can also be divided by 3.
No, we are talking about the
And
least,
it can.
we are talking about the least common multiple, right? Not common factor. Right. What are the multiples of 9? Multiples of 9 are 9, 18, 27, 30, 36, 45. What are the multiples of 12? It is 12, 24, 36, 40, 48, blah, blah, right? So among this, which one is the smallest? That is 36. We are talking about the multiple, not factor. Okay?
Oh, like what 9 can be multiplied by?
Yeah, what numbers are divisible by 9? What numbers are divisible by 12? We call them multiples, right? What numbers divide a number? We call them factor. Okay? For example, what are the factors of 9? Factors of 9 are 1, 3, 9. But what are the multiples of 9? It is 9, 18, 27, blah, blah, blah. Continues. Okay, to get the multiples of 9, I should just divide 9 by natural numbers. 1 times 9, 2 times 9, 3 times 9.
Big though. Yeah, I understood.
Very good. Guys, actually, maybe the first time, I don't know, if you practice a few questions, you will see that these are very, very easy. But just, you need to practice. And if you understand this, it will help you a lot to understand other subjects. Okay, very good. Guys, let's go move. So as you see here, now that's the main idea. So every time using this method, maybe these are small numbers, 12 and 9. If I ask a big number using this method, it's not so practical. What is the practical way? This is a practical way. It is much, much faster. Okay, finding the least common multiple. Another example, find the least common multiple of 30 and 36. Let me just use green. Okay, to do this, again, we should just write 30 and the 36 next to each other, draw a line, start dividing by 2. So it is 2, here we have 15, 36. Divide by 2, 15, 18. Divide by 2, 15, here we have 9. Now, 15 and 9, I can divide by 3 because 15 and 9, they are not divisible by 2 anymore. So next prime number is 3. Divide by 3. 15 is divided by 3. It is 5. 9 is divided by 3. It is 3. So still we have a number that is divisible by 3. Divide by 3. Here we have 1. Here we have 5. Now I already stopped when is 1. So now I should divide the next number by 5. Here we have 1. All are 1. So now what is the least common multiple of 30 and the 36? That's equal to 2 times 2 times 2 times 3 times 3 times 5. That is equal to 2 times 2 times 2, that's equal to 8. 3 times 3, that's equal to 9. And 5, right? And how do you multiply this? I better multiply this 8 by 5 first. That is 40. And 40 times 9, that is 4 times 9, it is 36. And we just put 0 here. So dot, dot, dot. Least common multiple of 30 and 36 is 360. What does it mean? We have a lot of numbers actually that are divisible by 30 and 36 simultaneously. But among these numbers, which one is the smallest one? The smallest one is 36. That is a mathematical way how to find that number. Sadiq, is it clear?
Yes, I understood everything.
Shamil, how about you? Do you understand?
Yes.
Very good. Sadiq, is it your puppy or you just got this picture from the internet?
I took from internet.
I see. Good. It looks very real. Okay, guys, how about if we have 3 numbers, not 1, I mean 2. At the time, again, the method technique is the same. We have to write these numbers next to each other, 18 and 24, and here we have 36. And draw a line and divide by 2. Divide by 2, here we have 9, here we have 12, here we have 18. Still, we have some even numbers. I can divide by 2, 9 and 6, 9. Right? And still I can divide 6 by 2, divide by 2. Here we have 9 and 3, 9. So now I can divide these numbers by 3. So here we have 3 and 1. We should stop this one and this 3. And still I can divide one more time. Here we have 1 and here we have 1. All are 1. So least common multiple of 18, 24, and 36 is equal to 2 times 2 times 2. We have 3 2's, right? And here we have 2 3's times 3 times 3. And that's equal to 2 times 2 times 2, it is 8. 3 times 3, it is 9. So that's equal to 72. So the smallest number that is divisible by 18, 24, and 36 is 72.
Mister,
Yes.
but GCF, it will be 24. Yes.
Say again, what did you say?
I'm thinking in this question, the LCM is 72 and GCF will be 24.
Not 24. Here, 18, 24, 36, all are divisible by 2. And here 9 is not divisible. Here 9 is not divisible, but here all numbers are divisible by 3, right? So highest common factor of these numbers is equal to 2 times 3 is equal to 6. Okay, if you divide 18 by 6, that's equal to 3. 24 by 6 is equal to 4. And 36 divided by 6, that's equal to 6. But this 3, 4, 6, they don't have any common factor except for 1. So the highest common factor is 6. Least common multiple is 72. Okay?
Yes.
Okay. And guys, here, before I continue, all right, let me just do something. Soon actually we'll talk about this. In math, as you see here, for example, what is multiplication? For example, if I have here 4 plus 4 plus 4 plus, let me just write only 3, 4. Okay,
Oh,
Yasmin, can you tell me? Huh?
May Neil say, Neil.
Yes, Neil, what do you want to say? What are you saying?
You can multiply this easier. Just count how many there is. 3.
It'll be
And 4 you can multiply like
yeah,
that.
4 times 3 will be possible too.
Yes,
Yes.
equal
Yes,
be
very good. Neil, what I'm trying to say here. In mathematicians, when they were working this, suppose that we don't have a multiplication operation. Okay, we don't have multiplication. If you don't know this, how do you add this? 4 plus 4 plus, we just write like this. But you will see that how about if I have more? How about if I have 3 plus 3 plus 3 plus 3 plus 3, for example?
May I
Every
say?
time writing in this way was
count?
not so practical. It's a waste of time. And after that, mathematicians introduced new operation. What is it? Multiplication. If a number is added to itself, let's say 3 times, simply we can just write it as 3 times 4. Here, 3 is added to itself how many times? 5 times. So simply in very compact form, I can just write it as 5 times 3. Okay. Now, similar to this, how about if we have multiplication? Like, for example, let's say 2 times 2 times 2. Okay. How can we
You
write this one in a very compact, simple form? And mathematicians introduce another notation. What is it? If a number is multiplied by itself, let's say here 3 times, simply you just write the number. And in superscript notation, just write here how many times 3. Just put here 3. So how do you read this? We read this as 2 to the power of 3. Okay, how do you read this? 2 to the power of 3. Or simply with this 3,
we
just read it 2 cubed.
we
But
learned this
2 to the
also.
power of 3 means 2 is multiplied by itself 3 times. And how about this 3? 3 times 3, right? So here we have 3 is multiplied by itself 2 times. So I can just write it as 2 squared. What does it mean? I just write it, read it as 3 squared or 3 to the power of 2. I will just show you some more examples. Squares and the square roots. Before we continue, okay, I don't have space here. So like, for example, just examples. Here we have 4
May I
times
say what
4 times 4, for example. Like in exponent form or power form, how do you write this? I can just write it as 4 to the power of 3. Actually, what does 4 cubed mean? It means 4 times 4, 16. 16 times 4, that's equal to 64. And how about 2 times 2 times 2 times 2? That's equal to 2 to the power of 4. What is 2 times 2? 4. 4 times 2, 8. 8 times 2, that's equal to 16. Okay.
by
you see?
dot do you mean multiplication? Dot.
Sorry?
You wrote there like 2.2. Do you mean like dot means
Yes.
multiplication?
Now, sometimes, guys, we will start using this. For multiplication, either I use multiplication or this dot, okay? Not decimal number. If I write like this, 5.2. This one is point. How about this one? 5 times 2, okay? These are different. This one decimal number, 5.2. This one is 5 times 2. Sometimes we will just use them interchangeably, all right? Sometimes if you get confused, I just use this one. If you don't get confused, I will start using this one because after grade 6, you must start using this multiplication as a dot.
May I say what we should do here? Squares and square roots.
Yes, guys, about, okay. So now let's talk about square and square roots and also again about this, what is it? Powers, we will talk about them soon. Now, boys and girls, here we are going to talk about two things, two concepts. Number one is squares, okay? And second one is square roots. So what do we mean by square? As you see here, what is it? We see here a square, right? All sides are equal. It is a quadrilateral where all sides are equal. Also, these angles are 90 degrees. So
I have a question
do you
about
find?
this.
Yes.
Totally, is it gonna equal 71? Totally, like outside perimeter.
71.
No, I know it's like 36, like like I know like 6 and the other side is 6, the upside is 6. I just took 36 from this side and oh no, sorry, I accidentally did it. Right now I came.
All right. So guys, here, what I'm trying to say here is one side of the square is 6 and this side is 6. And how do you find the area of the square? Let me just denote this area by capital A. Okay, A means area. Usually we use something like this, just the first letter. For area, we use A. For perimeter, we use P. For time, we use T. For diameter, we use D, right? For circle, I can just use C. I mean, it's like, how does it, to save time, okay? So we call this variable in math. What is the area? Area is 6 centimeters times 6 centimeters, right? This is how we find this. And that means that 6 times 6, actually, how do I write this? 6 times 6, that is 6 squared. Cm times cm, that is cm squared. Now we know what we mean by 6 squared, right? What is 6 squared? It is 36 cm squared. Okay. So actually, guys, you have to write all of these numbers and try to memorize. If you memorize at least until 20, it will be great. For example, what is 1 squared? We call them squared numbers. It is 1. What is 2 squared? It is 4. What is 3 squared? It is 9. What is 4 squared? 4 times 4, it is 16. 5 squared, it is 25. Guys, can you turn on your camera for just 2 minutes?
Yes,
I want to ask questions. Neil, what is 6 squared?
So 6 squared 2 is 6 multiplied by 6.
What is the answer? What is 6 times 6?
36.
36.
Okay, Stepan, what is 7 squared?
7 square is V7 multiplied by 7, it's 49.
Okay, 49. All right. Okay, I can continue here. What is 8 squared?
It's for me.
64. 64.
All right. Guys, you understand, right? To get the square, just we should
Yes,
multiply a
yes.
number by itself. Now, I will introduce the square root, okay? What do we mean by square root of number? Let's say square root of 9. What is it? It means that what number's square is 9. So what is that? That is 3.
Can I
Okay.
answer?
Yes, what is
3.
square root of 16? Nazla,
It is 4.
4. What is square root of 100?
10.
10. What is square root of 144?
Can you do 2?
Can you do it? What do you mean? What is square root of 144? What numbers
It's
square root
20.
is 144?
Sorry, it's 20.
12, right?
22.
Oh, yes.
12. Because 12 squared is equal to 144. Okay? All right, just you need to practice until 20, okay? When I ask, what is 20 squared? 400. 25 squared? 625. 27 squared? 729. Okay, 28 squared, for example, 864. You should practice these numbers. All right. So guys, let me finish here. I am going to give you some homework, or I'm already give this. You're already in the group. Okay, exercise 1A and 1B. Try to solve those questions. Okay, if you don't understand, I also already put the answers. Solve it and compare the answers. If you solve it correctly, it's fine. If your answer is different, bring this to the class. Mr. Qasim, I solved this, but my answer is different. Or Mr. Qasim, I tried this, but I am struggling with this question. I don't understand. Can you explain? I will explain, because I should know what you understand, what you don't understand, so that I can teach better. Yes, Neil.
I have a question about the 144. What did you write here? 12 using arrow. I don't know if it's you did multiplication really fast.
Which one? You mean this one? I just
Yeah, here you did.
arrowhead.
Oh,
Okay, they mean the same thing. Okay. Okay, guys, that much is enough. Try to solve your questions, especially word problems. Try to understand every word. Once you get used to it, then after that we have to speed up. Okay, if you need to practice a bit more problems, and because it's like, just let me give you one example. After that, I will finish today's class. What you are learning here is, it's like you have a knife. All right, you're just sharpening your knife. If your knife is dull, it's not sharp enough. Even if you try to cut a carrot, you cannot cut it well, right? It's so difficult. Even sometimes you cannot cut even bread. But if your knife is very sharp, you can just cut everything very fast and easily, right? So it is like this. Now maybe your knife is not so sharp, okay? By practicing more and more problems, and after a certain time, you will see that you can solve any kind of question of your level. So to reach this level, you need to practice as many questions as possible. Only by practicing more problems, you can be perfect, okay? Guys, thank you very much. See you next week then, okay? Keep doing practice. If you don't understand anytime, you can just ask me, okay? Just drop your question. What's up? I will try to answer your
yes.
questions, okay?
Okay.
Yes.
Okay, guys.
Bye.
Bye-bye then. See you next week. Take care. Have a nice weekend.
Goodbye. Have a
Bye-bye.
nice week.
Thank you.